Today, we're diving into something truly incredible, the actual blueprint for the next generation of robotics. And we're not just talking about clunky machines here. We're talking about a complete guide for creating intelligent, physical, humanoid robots that can walk, think, and interact with our world. So let's get right into it.
I mean, it's a question that feels like it's straight out of a movie, right? But this is rapidly becoming one of the most pressing engineering challenges of our time. It's not just about snapping some parts together. It's about creating a machine that can genuinely perceive, understand, and then act in our messy, unpredictable world. So how on earth do we actually do it?
Well, the key to tackling a challenge this massive is to see it as a journey. Let's call it the roboticist journey. The idea is that you don't solve it all at once. Instead, you follow a really clear roadmap where, as this quote says, each module builds your robotic superpowers step by step. And today, we're going to walk through that exact map.
So here's our game plan. First, we'll explore this new frontier called physical AI. From there, we'll get our hands dirty with the core tools every single roboticist needs. Then comes the really fun part, giving the robot a brain. After that, we'll see how that brain has to deal with the unique challenges of a humanoid body. And finally, we'll look at the kind of starter kit you'd need to begin this quest yourself.
All right, let's jump right in. Section 1, the new robotic frontier. Before we can even think about building anything, we have to get our heads around the revolutionary concept that's driving all of this, physical AI.
So, what is it? Well, physical AI, or you might hear called embodied intelligence, is all about bridging this huge gap between the digital world of pure code and the physical world we all live in. The absolutely crucial point here is that it's not enough for an AI to just be smart inside a computer. It needs a body to actually do things, to learn from physical cause and effect. This is where AI literally gets its hands dirty.
And you've got to understand, this is a huge shift in how we think about engineering. This isn't your classic approach where you build a machine and then maybe bolt on some smart features later. No, this is what we call an AI-native approach. That means AI is at the very heart of the design from day one. The body is designed to serve the intelligence, and the intelligence is designed to operate that body seamlessly.
Okay, so we've got the philosophy down, but what are the practical first steps? That brings us right to Section 2, Mastering the Core Tools. This is all about building that solid bedrock of skills that everything else is going to stand on.
This whole journey really begins with 3 foundational modules. First, you have to learn the language. In this world, that's ROS2, the robot operating system. Think of it as the universal translator that lets the robot's brain, its sensors, and its motors all speak to each other. Then you step into the virtual world. You build a digital twin to test and train your robot in a simulation, which is just a super safe space to fail and learn without breaking thousands of dollars of hardware. And finally, you get hands-on with the physical stuff, the motors, the sensors, the control boards, basically the robot's muscles and nerves.
Okay, this is where things get really cool. We have the body, the language, and a practice space. Now it's time for that spark of intelligence. Section 3 is all about giving our robot a brain.
And the secret sauce to this brain is a concept called the VLA superpower. It sounds cool, and it is. It stands for vision, language, and action. And it's pretty much the modern way to create perception and intelligent behavior in a robot.
Let's break that down, because it's super important. V is for vision. That's how the robot perceives the world, seeing with its cameras. L is for language, which is how it understands what we want it to do, like if you tell it, pick up the red block. But A, action. That's the magic that ties it all together. It's the ability to translate what it sees and what it's told into an actual physical task. The robot doesn't just see the block. It calculates exactly how to move its arm, turn its hand, and apply just the right amount of pressure to grip it. That's action.
Now, to make that happen, the robot has to learn. It uses a process called reinforcement learning. You can think of it as digital trial and error, basically. It tries a task, gets feedback, and gets a tiny bit better, over and over again, thousands of times in that simulation. Then, the absolutely crucial step is sim-to-real transfer, where it takes everything it learned in that safe virtual playground and applies it to the real world. And this whole dance is managed by incredibly complex control systems that make sure its movements are smooth, stable, and precise.
So once we have those foundational skills and that AI brain humming along, we can finally take on the big one, the ultimate challenge. Section 4, Designing a Humanoid. This shape, this form factor is amazing because it's designed to operate in a world that was built for us, for humans. But wow, does it come with some massive engineering hurdles.
This slide really hammers home just how mind-bogglingly difficult this is.
Just walking on two legs, something we do without thinking, is an incredibly complex balancing act for a robot. To keep it from falling over, engineers are constantly calculating things like the zero-moment point, the exact spot on the ground where all the forces are perfectly balanced. Then you have to coordinate the entire body, making sure the arms don't swing out and throw off its balance. And on top of all that, you have the immense challenge of designing a hand that's dexterous enough to actually pick up and use everyday tools. It's a huge list.
So this all sounds amazing, right? But you might be wondering, okay, what would I actually need to get started on this journey? Well, our final section covers exactly that. Section 5, your robotics starter kit. This is the recommended gear for the quest. Your kit really has 3 key parts. First, you need a command center, a powerful workstation PC with a good NVIDIA graphics card. This is where you'll run those heavy simulations and train your AI models. Second, you need an edge AI kit, like an NVIDIA Jetson. This is a small but very powerful computer that actually lives on the robot, running those AI models in real time. It's basically the robot's onboard brain. And finally, of course, you need an actual robot, something like a turtlebot, to deploy your code on and see it all work in the real physical world. So, here's the big takeaway from all of this. What used to be the stuff of pure science fiction is now becoming a real, structured, teachable engineering discipline. The modules, the tools, the AI frameworks, it all adds up to a comprehensive blueprint. The path to building intelligent, embodied AI is no longer some deep mystery. It's a map, and it's just waiting to be followed.
And that leaves us with one final and pretty powerful question. We have the roadmap, we have the tools, we understand the principles. So the only question left is, what are we going to choose to build with them, and how will these incredible creations ultimately shape our world?